In today's lesson, we're going to graph square root and cube root functions. So we've talked about graphing square root and cube root functions before, and so we'll just kind of review what we've spoken about before with these and add just a few little things to it. So when we're graphing these, we want to pick a few key points. So let's look at the parent functions here. On the left I have the square root parent function, and one of the key points is 0, 0. So it starts at the origin, and then 1, 1. So the parent function always goes through 1, 1. Since if the input is 1 for x, take the square root of that, you get 1. So anything that's a perfect square will give you an integer output. So like 4, 1, 2, 3, 4 would give us 2. So that would be another good point to plot and label. It'll be important to make sure that you label these points. And then further down, if you have the space, and you should, 9, 9, 3 would be another point to plot, and I would extend it like so. And our domain x is greater than or equal to 0, and our range is y is greater than or equal to 0. For a cube root, it would be easiest to plot points where x is a perfect cube. So it starts at the origin, and 0, 0, the cube root of 0 is 0, and then the cube root of 1 is 1. The next perfect cube would be out at the side, which would be 8, because that's 2 to the third power. So cube root of 8 is going to be 2. So that point would be 8, 2. And then it would extend out in this direction. And of course, it's going to be heading in the other direction as well. So if you have negative 8, you'll get negative 2. So it extends out in this direction. So knowing these key points to plot and label is going to really help us graph these functions. And to review the general form of both of these, we have for the square root, y equals a x minus h plus k, where h is the horizontal shift and k is our vertical shift. And then for the cube root, same idea, except we have a cube root. Remember that the h works backwards because of that minus sign. So a left shift is going to have a plus h, a right shift is going to have a minus number, or minus an integer, or whatever you get. So let's look at an example here where I want to graph actually y. Let's correct that. Well, I want to graph y equals 3 square root of x plus 2 minus 4. So we have an a value. It's 3. It's a number greater than the absolute value of 1, and so that's going to be a vertical stretch. And I'm going to start off and graph that, and then I'll do my translations. So basically, if we recall the parent function, it starts at 0, 0, and we're just going to take each of these points and then we're going to multiply the y by 3. So because it's a vertical, and y works on the vertical, so it's a vertical stretch or shrink, in this case vertical stretch. So we recall that originally we'd have 1, 1, okay, square root of 1 is 1, but we're going to multiply the y by 3, so when x is 1, it's going to be, y is going to be 3. So I would label that 1, 3. And then the next perfect square would be 4. So that would be 4, 2 on the parent function. Square root of 4 is 2. But then we're going to multiply that by 3, the y value. So that's going to give me 4, 5, 6. Or let's see, 1, 2, 3, 4, 5, 6 right here. So that's going to give us x is 4, y is 6. And I can do one more. We can do 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So square root of 9 is 3, but we multiply that by 3, so that's going to give us 9 here. So when I stretch that, that's going to be 9, 9. Okay, so this graph is simply going to look like this. Now this is just a stretch, okay? Now what we'll do is we're going to take that stretch and we're going to shift it left 2 because of the minus or plus 2, and then down 4. So where I'd start at 0, 0, 0, 0 is always a great point to start when you're doing your translations. So what would be 1, 3, we're going to go left 2 and down 4. 1, 2, 3, 4. So 1, we subtract, or 0, 0, subtract 2 gives us negative 2, and then down 4. So it's just going to be HK in this case. So negative 2, 4. And then we'll do the same thing here. So 1, 3, so we go left 3, so 1 minus, or left 2, so 1 minus 2, and that's going to give us negative 1. And then 3 minus 4, that's going to give us negative 1. So down 4. And I'll label that as negative 1 and negative 1. And then 4, 6. Okay, so left 2, 4 minus 2 is 2. And then down 4, which will put us at positive 2. 6 minus 4. So that's going to be 2 and 2. And then finally we can take 9, 9, and then go down left 2, 1, 2, and then down 4. And 9 minus 4 is going to give us 5. So I'll write that as 7, 5. I connect those points, and we've successfully translated our graph. So this would be our final equation. So this would match up with that guy right there. Okay, so that's a square root. So in our second example, we're going to graph a cube root function. So we're going to graph y equals 1/2 cube root of x minus 2 plus 3. I'll start off with the a value, which is 1/2, and that's going to be a vertical compression since that's less than 1, and so or vertical shrink is also what it's called. So when I do this one, I will go ahead and recall the parent function starts at 0, 0, so that would be my starting point. And then I'm going to pick all the perfect cubes, so or all the perfect cubes that I can get in here. So 1 would be one of those, and so the cube root of 1 is 1, but we're going to do 1/2 of the y value, so that's going to be at 1/2, so it's going to be down here. Then the next cube root value is going to be 8, so I'd count to be 1, 2, 3, 4, 5, 6, 7, 8, and that cube root of 8 is 2, so that would, the parent function would be here, but we're going to do 1/2 of that, so it'll be at 1. Okay, so here I have 1 and 1/2, and then the next one's going to be at 8 and 1. And then the cube root function we know goes the other direction. It's just kind of reflected over y equals x. And let's see, so that's going to be negative 1, negative 1/2, and then negative 8, negative 1. So negative 8, negative 1. And then I'll draw that as best as I can. Again, it's really hard to graph like this. It's much easier to do it on paper. Okay, so the next thing I want to do is then I'm going to translate it. So -2 tells me all these points are going to go right 2 and up 3. So I'll start off with the origin, 0, 0, and so again that's just going to be hk. H is 2 and then k is 3, so 1, 2, 3, and I'll label that 2, 3, make that clear, and then I'll do the next one. So I'm going to take this, go right 2, so 1 plus 2 is 3, and then I'm going to add 3, or go up 3, 1, 2, and then 3, so that's just going to be 1/2 plus 3, which is going to be 3/2. So I'll label that as 3 and 3.5. And then finally 8, again right 2, so I'll put it 10, and then up 3, so 1 plus 3 is going to be 4. So 10, 4. And then we're going to go the other direction, and my next point is going to be 1 and 2.5 as we go in the other direction. And then the final point, so we -8, 1, so -8 plus 2 will put us at -6, and then we'll add 3 to -1, which will put us at 2, so -6 and 2, and then we'll connect those points to the best of our ability to show our curve. There we go. So that would be my cube root, more or less. Ugly graph, I know, but try the best we can. Alright, so anyway, that's graphing square root and cube root functions.